All right, find the particular solution to the equation dy dx equals 2x minus secant squared x, whose graph passes through the point 0, 3. And you'll notice that on this particular one, secant squared is going to have several discontinuities where you've got vertical asymptotes. Don't panic. As long as we are looking at a point that is actually on the graph, we should be able to work this out. We would just look at that particular place on the graph, that particular interval where things happen correctly. So here we go. Dy dx equals 2x minus secant squared x. Multiply both sides by dx. And what you're going to end up with is dy equals 2x minus secant squared dx. And we can now we can integrate. So this is actually no different than solving out for y in your former algebra life. You're just getting that y part all by itself, but we're adding to our bag of tricks now, integrating. And instead of multiplying or dividing both sides or using a logarithm or something like that, something that you've done in the past to isolate the y, we're now going to add this integration to that. You end up with then y equals, and then think about this, x to what power? So this was first power, so x squared. Derivative of this has to be 2, so it would just be x squared. And then derivative of what is secant x? And the derivative of tangent x is secant x plus c. So now we're talking about like tangent x. Well, remember that with the tangent, we've got sine over cosine. So when we combine those graphs together to get our tangent graph, remember that we're going to have asymptotes at pi over 2. And that our graph is going to look something like this. We're going to go through 0 here. At pi over 4, we're at 1. Negative pi over 4, we're at negative 1. So it's a graph that looks something like that. Okay. The reason I draw the tangent graph is we know that x squared is defined everywhere. So if we look at x squared, if we look at this graph, we're looking at this situation. So we're looking at a combination of these two things. Here's the deal. We need to be defined at 0. 0 is the x coordinate. We need to make sure we're not on an asymptote, and the tangent determines where that asymptote is going to be. Okay? So when we're looking at 0, if we look at both of these graphs, at 0 we are defined at 0 on both. That doesn't mean we'll be 0. We could be, but we know that we're okay there. So what do? Well, we use the old rule that if they give me a point, they've given me an x value and a y value. So I'm going to plug in a 3 for my y. I'm going to plug in zeros for x's. And I'm going to solve this bad boy out. So this is going to be 3 equals 0 minus tangent of 0, 0 plus c. And as it turns out, they both are 0 at that spot. And so how do we finish this guy up? Well, we use this part of the information that we discovered through antiderivative, and we use this guy down here as the constant. So y equals x squared minus tan x plus 3. So there you go. There's dealing with a discontinuity. And if we had been over here someplace with tangent, remember it's periodic and it repeats. So if we had been over somewhere in this space, we would just need to have checked to make sure that this point could be a possibility to lie on that line for the x coordinate.